Hello, everyone. It's a pleasure for our company to present our latest solution to you. Today, I will introduce our DFU, Device Firmware Update, technology. The content of the introduction primarily consists of 4 parts: DFU Overview, the Dual Bank Mechanism OTA, over-the-air, and CFU, Component Firmware Update. DFU Overview. DFU refers to the process of upgrading device firmware. The SDK supports 1. OTA via Bluetooth. 2. CFU via USB HID or BREDR HID. The functions of DFU include 1. Fixing bugs or vulnerabilities in the device. 2. Adding new features or improving existing ones. 3. Optimizing device performance. 4. Updating device security to protect against new threats. Dual bank. 2 bank areas, including Bank 0 and Bank 1, are allocated to store firmware images. Only one bank is active at a time, while the other remains as a backup. The versions of the images in the 2 banks are compared sequentially until a difference is found. The bootloader authenticates the bank with the higher version number first. The advantage of dual bank OTA is below. 1. There is always a backup bank, so users do not need to worry about the SoC crashing when the OTA process fails. 2. The bank switching process is fast. OTA. OTA refers to the wireless delivery of software updates to devices. The SDK supports OTA via Bluetooth and provides 2 Bluetooth transport methods for Android and iOS. 1. OTA via GAT, suitable for both iOS and Android. 2. OTA via SPP, suitable only for Android. To achieve OTA functionality, it is generally necessary to set up an OTA firmware upgrade system as shown in the figure. This application firmware upgrade system consists of 3 parts. 1. Cloud server, storing upgrade files. 2. Mobile device, the OTA controller role during the OTA process. 3. SoC to be upgraded, the OTA target role during the OTA process. The dual bank OTA flow is shown in the following chart. The mobile phone is the controller and the SoC is the target. The controller establishes a connection to the target before the OTA begins. Subsequently, the controller obtains the target information to determine whether the upgrade is authorized. Images pushed by the OTA tool will always be stored in the inactive bank during the OTA process. The SoC will reboot after all images have been pushed and validated successfully. Because the bank with all legal images and higher versions will be selected to be activated by the bootloader, the upgraded images should have higher versions and be validated successfully. Otherwise, the system rolls back to the previous version. During the process of pushing an image from the OTA tool to the SoC, we designed the following mechanisms to ensure correctness and efficiency. Buffer check. The function is enabled by default to detect transmission errors as early as possible. Encrypted transmission. The OTA tool and SoC support encrypted transmission and the algorithm AES-256 is supported. Image validation. The OTA tool will send the command to force the SoC to validate the entire image after an image has been fully delivered to the SoC. Image skip and copy. To improve efficiency, image skip and image copy mechanisms are designed to avoid unnecessary image transmission. After programming the application image to the EVB board, testing is performed via mobile devices. The OTA header generator and image pack tool are fully integrated into the MPPG tool. Generate OTA header image. Pack whole images. OTA with iOS tool. 1. Connect with the target device. The device information including the image version will be shown in the UI. 2. Select firmware and the firmware version will be shown below. 3. Start updating process. OTA with Android tool. CFU. CFU uses Microsoft's open-source license, providing a reliable and authenticated method for updating firmware on devices that have shipped to customers. The CFU protocol operates sequentially. Each host command requires a component response. The host proceeds only after receiving a valid response. In case the component doesn't respond within a period or sends an invalid response, the host resends the command. There are commands to get the version information of current firmware on the component, to send the offer and to send the firmware image. CFU firmware version request report is used to obtain information such as the device version. CFU firmware offer reports is used to inform the device about the upgrade file information. CFU data report transmit upgrade data. After programming the application bin to the EVB board, testing can be done with a PC. The CFU packaging process is similar to OTA. Choose IC type and CFU type. Get device information and download. Thank you.